So this was a webinar I did a couple of weeks ago. What I'll do when I'm finished and Jack starts presenting, I'll grab the link for it and I'll stick it out in the chat as well so that you've got that. My computer is going really slow right now. I probably should have rebooted, but we'll give it a whirl and see how it does. Okay, so everybody should be able to see my screen here now.
Yep.
Okay, so the scenario is around a Teams provisioning solution that we've had for a couple of years that we've built at Extranet User Manager. And the idea is a self-service, SharePoint Framework web part form that you can fill out to say, hey, I want a new team or site, and fire into some Logic App automation and Azure automation to provision that out. And I'm not going to get into the solution itself, but there's some SharePoint Framework web parts that need to get deployed. There's a couple of Azure Logic Apps that need to go out. There's some Azure automation, some PowerShell running up in the cloud as part of that. And basically, this is the solution architecture of the whole solution. When somebody comes to the SharePoint page or to Teams that has the web part on it, they can fill out a request through a SharePoint Framework web part. That request used to write directly to a SharePoint list. We took that out and said, hey, let's build proper security. That was a different topic. That when somebody fills that out, it triggers a Logic App workflow. We may want to use Power Automate as part of the approval, or we may want to just go straight down through here and actually do the provisioning. But the main lifting doesn't happen in the Logic App. It basically calls out to a series of runbooks in Azure Automation to say, hey, go do the PnP stuff and build out the team and the SharePoint site and the OneNote and the Microsoft 365 group, all those pieces as part of that. And we want to be able to deploy this solution out in an easy and repeatable way. And that's really where the ARM templates come in. That we've got basically a resource group in Azure that has all these components that make up this Microsoft 365 solution that we want to deploy out to another tenant, whether it's from dev to test to prod, or it's into a different client's tenant altogether, whatever the case may be from that. And Jack will get into the ARM template side, so I'm going to leave that piece alone. But a big part of ARM templates is that there's parameters to those templates. And also with Logic Apps and Azure Automation, there's parameters and variables in those services as well. But they're not connected to the ARM template itself. So we can build a template that's going to package and deploy all that stuff, but we need to do some specific tweaks beyond what Microsoft gives you out of the book to actually wire that together and have these resources properly configured and working from there. And this is where Jack helped us a lot. We had him working on this ARM template generator that basically, you point it at a resource group like that one I was showing and says, hey, I've got these Logic App workflows and Azure Automation, all this stuff in there. Just, capture all that, get the ARM template out for that. And you can do that through the portal. You can say, just export this template, but it won't be wired up properly. So can we parameterize that and have it connect up ARM template parameters to the parameters in the Logic Apps and in the Azure Automation so that everything connects properly and it's repeatable? Can we also have it export the templates so we can check them into Git and make them a part of source control and have proper software development lifecycle? So that's what that's all about, is the ability to capture that, to form that template in the right way, and to push it out. And then Jack also helped us on this ARM template deployer, which then takes that ARM template and deploys it out to a resource group. I mean, you could just go through the portal and say, hey, deploy a custom template and load your template and let it go. But again, there's things that ARM doesn't do out of the box, like things around the run as account, setting up the certificate and the service principal and permissions and stuff that needs to happen above and beyond what ARM template can do. So, really packaging that together and to say, hey, can we have a proper full software development lifecycle process around this that, I can work in a dev environment, in a dev tenant with Azure AD and SharePoint Online and Microsoft 365, build my stuff in the Azure portal, snapshot all that, get it into Git so it's there from a resource point of view, and then build a pipeline and do a proper continuous integration deployment process into my test, pre-prod production environments and manage it all through there. So that's really what this is all about, having that full continuous integration scenario through there. So I think that's enough backstory. It's just, if you're building these complex Microsoft 365 solutions that aren't just, something I did in SharePoint, but there's SPFX and there's resources in Azure and maybe there's workflows in in logic apps, and you got to tie all that together. ARM templates are a great way to pull that together with some PowerShell and say, hey, can we make this a repeatable, deployable process? So with that, Jack, I'll turn it over to you and let you take it from there.
Yeah, that's awesome.
I'm equally interested in where does this go, because this was all built sort of with the previous generation of ARM templates, which is not what Jack's going to be focusing on here today.
So let me share my screen. Let me know if you see my PowerPoint slide. Everyone seeing that okay?
Yes.
Yes? Okay.
Yes.
Well, first of all, thank you, Peter, for the introduction, and also thanking you for inviting me to speak at the TSPUG. I'm really excited to be here. Today, my talk is on Azure Bicep. It's the next evolution of ARM templates. Now, as Peter's introduction has alluded to, he's repeating the word deploying, provisioning quite a bit. So that's basically the nutshell. In a nutshell, that's what Bicep enables you to do, is to deploy resources in a way that's declarative. And you can have this recipe time and time again, producing the same type of provisioning. Now, before I begin to do the presentation, allow me to do a quick introduction for those who don't know me. I think I recognize a lot of faces, so this is probably just a rehash of who I am. I'm a Microsoft Azure MVP, Azure Certified Consultant, and I'm the president of the North Toronto Cloud and DevOps user group. If you'd like to join our user group, if you're not a member already, just simply go to northtorontoug.com. I'm also on Twitter, so if you're on Twitter, feel free to follow me. My account is jlee_consulting, and you can also follow my user group at North Toronto UG. I also have been writing books as like a hobby. So I'm an author. I've written 3 books: Cloud Analytics with Microsoft Azure, the Azure for Architects, and my latest book is Azure Strategy and Implementation Guide. My favorite book has got to be the Azure for Architects, because it's a very comprehensive end-to-end book, over 670 pages. So if you are pursuing, let's say, a Microsoft certification exam on Azure, definitely check this book out. It'll help you quite a bit. All right, let's get to our main presentation. When it comes to deploying your infrastructure on Azure, there are actually a number of ways that you can do it. Now, for beginners and for your one-off provisioning projects, you can definitely use the Azure portal. So that's basically a GUI-driven, step-by-step, wizard-like guided interface. Very easy to ramp up on, and the learning curve is very small. If you're into command line interface, if that's your preference, you could use the Azure CLI, which stands for Command Line Interface, as well as the Azure PowerShell. Now, if you really want to get into something like automation, infrastructure as code, otherwise known as IAC, is something that you would want to venture into. So it allows you to do automation, integrating Azure infrastructure provisioning as part of your DevOps CI/CD pipeline. You can do something which is known as the ARM template, which Peter alluded to earlier. So ARM stands for Azure Resource Manager. Now, given the popularity of ARM templates, it does have some difficulty when it comes to authoring ARM template, because the whole premise behind ARM template is a JSON file. JSON is nice, but it's sometimes difficult to read, especially if you have a very complicated template. So a new and exciting way of doing IAC that has been introduced recently is the Azure Bicep. You can call it Bicep for short. I call it Azure Bicep because it ties very closely to Azure provisioning. So it doesn't really confuse the people what bicep is. We're not talking about the muscle on your arms. But as you can see, ARM templates, right? ARM is a play on words with bicep. So that is the reason why they call it Bicep. It's just a play on words. So what is Bicep. This is essentially a domain-specific language, a DSL, for deploying Azure resources declaratively. It aims to drastically simplify the authoring experience with a cleaner syntax, improved type safety checking, and better support for modularity and code reuse. And this is the focus of our presentation today. So let's go through some of what we just talked about in more in-depth level. So using the Azure portal, as you can see here, is a very user-friendly, GUI-driven, step-by-step guided interface. To get to this portal, this is the URL, portal.azure.com. So as you can see, it basically goes through and asks you a bunch of fields to fill in, things like resource group, region, etc., etc. And you just click next and fill in the next form until you get to the very end where you create the resource that you want to create. It's very easy to ramp up on, and the learning curve is very small. But UI has its own difficulty too, especially when applications are hosted on the internet. It's very easy for the hosting company, or in this case, Microsoft, to make changes to the UI. So if you were to memorize or take screenshot of how things are represented today, user interface-wise, it could very well change the next moment you check it out. So a better way of provisioning, if you were to do repeated work, is by using code. So the first technique that we use is called Azure CLI, which stands for Command Line Interface. Here's an example of Azure CLI, the code, consisting of a number of lines of instructions. I'll give you a minute to take a look at this code, see if you can figure out what it does. If you figure it out, type it in the chat. We'll take a look in 1 minute, okay? Starting now. See anyone contributing? Create a new disk. Several people saying that. Rename a disk. Okay, interesting. Create a virtual disk. Any other guesses? Those are very good guesses. Copy. Oh, Peter's saying copy. Okay. Throw a disk. Like what, a frisbee? Nice try, yeah. Any more guesses? Once, going twice. Okay, so let me explain this. The same code, I put comments in there so you can have a look. And I'll explain. So firstly, I am defining a variable to store the subscription ID. So in this case, this is my subscription ID for Azure. Next, I declare the name of my resource group and the name of it. So this is basically declaring variables that can use later on without hard coding in the actual command. Next, I log into my Azure environment using AZ account set subscription, which I pass in the subscription ID that I define up here. The next command is basically getting the manage disk ID based on the parameters I've defined above. So I pass in the manage disk name, the resource group, and also I'm querying the ID to return to the manage disk ID variable that I define here and return it using tab separated values. So just capturing the ID. And I echo it back to make sure that I have captured it properly. If I get a blank, that means it doesn't exist. So realistically, I should put in more logic here to check if manage disk ID is actually defined. So let me clear this so it's not so messy. The next part is defining the target. Target subscription defined here. Target resource group defined here. And also I change, here I log onto the source subscription. Here I log on to the target subscription. So someone mentioned that copying, that's exactly what it's doing. It's copying a managed disk from one subscription to the other, copying from the source, in our case, to the target, keeping the same name of the disk. So Peter is correct. Congratulations. No prizes though, sorry. All right, so moving on to the Azure PowerShell example. So this one is very simplistic. Again, as a good practice, you should define variables up top so that you don't hard code in the actual command. So later on, if you want to reuse it, you can turn this into a function and pass in parameters as values that you could change dynamically. So the first thing I'm doing is I create a user object asking the username and password and storing it into $cred. And then I create a new resource group using the resource group name and also the location that I define here. Here's the bulk of the execution, is creating a new virtual machine, passing in every single bit of the definition I have declared above, name, location, resource group. And here, if I want to, I could also pull this up and define it above. But here I just put in hard-coded Windows 2016 data center is the VM image name that I want to provision with. Assuming that I've already set up a VNet, a virtual network, and a subnet, I pass them in, okay? And open up port 80 so that I can serve a web page. Next, and the final step is to install IIS. I'm doing it this way, using a call out to PowerShell to add Windows feature, turn it on the web server. So this is all done using the VM extension. So that's pretty cool using Azure PowerShell. But still a lot of code to deal with, right? So that's why ARM template is a more preferred choice because it's declarative, it's a recipe. You can see it's much cleaner too. So instead of all the PowerShell commands going back and forth, you're basically defining things like parameters you can pass in, local variables that you could manipulate, things that been passed in, or you want to create something unique that's going to be used internally within the ARM template. And finally, resources that you can define. In this case, in my example here, a very simplistic example, I'm not provisioning any resources. My goal of this ARM template is basically to pass the output to the next calling script. This could be a nested scenario, like one ARM template calling the next one and pass values back and forth. So in this case, I'm passing the hello world variable of string type using interpolation, string interpolation, format, the first parameter, second parameter. First being the variable, which is defined here, hello world dash hi exclamation, and the parameter, which is captured here as input value. So if I were to say pass in your name as Peter Carson, the resulting output for hello world would be hello world exclamation hi Peter Carson. So you can see that ARM template is pretty powerful and also pretty simple in terms of provisioning, right? All you have to do is pass in parameters. If you want to, optionally, have your variables to deal with manipulation of values, provision your resources. Again, in my simplistic example, I'm not doing anything, but you could conceivably put in things like virtual machines, virtual networks, SQL database, app services, and so forth in this section. And finally, if you want to relay this output to the next calling template or just to display it, whether it's successful or not, you could have outputs of parameters that are defined within the ARM template. Cool. But still, this is JSON, right? This is a simplistic example as well. But if you have a very complicated ARM template, this could like go to hundreds of lines of code. So let me introduce you to Azure Bicep. What you're looking at here is 4 lines of code, 1, 2, 3, 4. But actually, this one is only a comment. So literally, you're looking at 3 lines of code, 1, 2, and 3. And guess what? This is doing exactly the same thing as the ARM template example that I showed you earlier. So here you see parameters. I'm using the same variable name, your name, of type string. A local variable called hello with a predefined string of hello world exclamation dash hi. And I'm outputting using hello world as the name of the variable of string type. String interpolation, look at this, how clean this is. Simply a quote, $ referring to hello, this variable here, and $ your name, which refers to the parameter that's being passed in. 3 lines of code. So let me do a side-by-side comparison. Look at this. Here's the ARM template. Here's the Bicep template. 1, 2, 3 lines of code. ARM template, up to 27. Amazing, eh? Any questions so far from the audience? Let me check the chat. Okay, so Eli earlier said, oh, cool, across subscription means that across tenants work too, from my dev environment to client's test. Of course. Yep. And Peter gave a thumbs up. Thank you. So we'll continue. No questions so far. Okay, so let's take a deeper dive into Azure Bicep and understand what it is. So Azure Bicep, by definition, is a new declarative domain-specific language, a DSL, for deploying Azure resources. Now, when I say DSL, that means it's not a general language. It's not going to be able to play sound file, cannot play video, right? This is specifically for deploying, provisioning resources on Azure. So Azure Bicep, what problem does it solve? How come Microsoft invented Bicep? Well, the goal of Azure Bicep is to make it easier to write IAC, targeting ARM using syntax that's more readable than JSON syntax of ARM template. I think we all agree by looking at this side-by-side comparison, I would much prefer to deal with 3 lines of code as opposed to 27, right? Okay, so let's talk about how it works. Well, Azure Bicep works as an abstraction layer that's built on top of ARM template. So what that means is essentially anything that ARM template can do today, Azure Bicep can do it as well, because Bicep is basically a transparent abstraction layer that sits on top of Azure Resource Manager ARM. So with this abstraction, all the types, API versions, properties, anything that's valid within the ARM template, whatever you have, right? They're valid within Azure Bicep. Continuing with the explanation of how it works, Azure Bicep is a compiled, transpiled language. So imagine, I think most of you are familiar with JavaScript, right? So JavaScript could be challenging to read sometimes because of the way that it is grown over the years. So this is similar to how TypeScript has helped JavaScript in that it's making it object-oriented, easier to read. But in order to get to execution, you got to transpile or compile it back into JavaScript form. So Azure Bicep code works exactly the same concept, right? It has to convert into ARM template code in order for execution. But nowadays, Microsoft has built in mechanism where it does the transpiling and compiling behind the scenes. So you could actually call the same deployment command. I'll show you in the demonstration later on, straight through a Bicep file into the deployment code, and it will deploy without you having to take the extra step of transpiling and compiling into ARM template. It's pretty neat. So all that talk about how it works and what it does, how do we get started? Pretty simple. So first of all, I think most of you, 99%, maybe 100% of you would have Visual Studio Code installed on your machine already. So all you need to do to make things easier, you don't have to, but I would much recommend it, is to install this Bicep VS Code extension, which looks like this. It's made by Microsoft, so you could trust it. It's a first-party extension. And also install the Bicep CLI. And finally, have something like Azure CLI or Azure PowerShell to help execute the deployment of it. So I'll show you that in the demonstration. I will copy this link in the chat, so if those of you want to follow along, the installation doesn't take too much time. I'll paste it in the chat in case you want to try it out right now. Give me a moment. And there you go. Okay, it's time for a demo, my favorite part of the presentation. So I'm going to do a 5-step demo, starting from the very basic to more advanced. So firstly, I'm going to create our first Bicep template. Secondly, I'm going to show you how to add parameters so that it's not so rigid and static. It'll be dynamic. You can pass in things to change values and so forth for repeated deployment. And I'll show you how to use built-in template functions. So things like unique values, location, resource group location. You can pull that dynamically from template functions without hard coding. And show you how to add variables. And finally, show you how to do the outputs. All right, so let me flip to my demonstration screen. Give me a moment. Okay. I think the screen has come up. Okay, just to show you that I have nothing up my sleeve, even though I'm wearing a t-shirt. I have only 3 resource groups, okay? So let me begin by creating a blank template file. And I'll call it Azure Deploy Bicep. So if you name it with the extension Bicep, and if you have the extension that I showed you earlier, the Bicep VS Code extension, then you have your syntactic help as you're typing. So I'll show you that in a moment. Okay, so first, let's create our Bicep template. Let's do a resource of storage account, STG. And you can see the hint being displayed because you have the extension to help you. So put in quote. You can type anywhere in the middle. It'll pull you the correct value. So in this case, we're looking at the resource provider of storage account. So I'll type in storage account partially, and it brings it up. I'll click that. What you see here are the API versions. So let's be adventurous and go with the latest, okay? You could also go backwards in time and select a different version, like 2016 if you're supporting something that's legacy. Okay, equals, and in this scope, I will have a name of the resource, not the resource, the storage account. it has to be globally unique across Azure. So let me come up with something. TSPUG 2021-05, today's date, 19. That's probably unique. And location. So right now, I will hard code it to say East US. SKU is also a scope that you have to define. So in this case, I just define a name of the tier that I want. Let's go with standard LRS. The kind of storage, let's do version 2. There's version 1, version 2, blob storage, file storage, block, blob. So let's do version 2. It's the most popular. Properties, let's define some properties here. To support HTTPS traffic only, so make it more secure and encrypted. And that's all we need. So let's do a save. For the deployment side, I would hop onto Azure CLI or Azure PowerShell. So firstly, connect to your Azure subscription. So that's done by using a connect AZ account. So I've already connected, but if not, it's going to ask you to authenticate. Authentication completed, and you can close this. And that's all. That's very simple. One-liner and display that. All right. And next, do a new Azure AZ resource group. So I'm going to create a new resource group in my Azure subscription. Let's call it TSPUG. Again, make it somewhat unique, 2021-05-19. And location. This time, let's bring it to Canada Central. Press enter, let it go, done. So if I were to go back to my Azure portal, remember I started out with 3, so nothing, no tricks up my sleeves. If I refresh a couple of times, it's going to take a while for Azure to catch up to the CLI PowerShell commands, but eventually it'll come up. So just click refresh a couple of times. There we go. So it has been provisioned. If I click in there, it's empty, right? So because all I have done so far is to create the resource group, which is basically a container of resources that you will provision next. The purpose of a resource group is so that for billing, you can check one central area. For cleanup, also delete from one central area, and all the subsequent resources will be deleted, or if you're doing billing, you can see everything collectively in one container. Okay, so let's get back to here, do the actual deployment of the Bicep. So let me define a local variable called Bicep file, and give it the name that we called it Azure deploy.bicep, right? Azure deploy.bicep. There we go. And the command to deploy is pretty simple. It's new AZ resource group deployment. There we go. Pass it the name of the deployment. You can call it anything. Let's call this first Bicep, right? Could be anything. Could be Mickey Mouse and so forth. Resource group name. We'll call it whatever we created. We called it the TSPUG 2021-05-19. And finally, pass in the template file, which we have defined a local variable for. No hard coding here. And press enter. So what it's doing is connecting to the Azure subscription and doing the provisioning based on our file here, the template. Let that run for a little bit. So In the meantime, let me check if there's any question in the chat. Feel free to ask any question. All right, completed. So whenever you do a deployment, the thing to watch out for is the provisioning state. If you see the word succeeded, then everything is hunky-dory. If it's failed, then go back and troubleshoot and debug and see what happened. Maybe missing a brace, or maybe the value is incorrect, parameters used incorrectly. So just troubleshoot. So in our case, success. Let's hop back into our Azure portal. As you recall,
can we deploy code with a template?
Deploy code. What kind of code? Like a website? ASP.NET?
Azure function. An Azure function.
Yes, of course. Azure Functions is definitely feasible, as well as app services, such as a full-blown website, containers. Yeah, anything that you can think of that could be hosted within your Azure subscription could be deployed using this technique.
Okay, and how would include the code within that?
One at a time, sorry?
I would deploy a DLL, not the source code, I take it?
Well, okay, if it's a DLL, then you're talking about a .NET app, right? So then you would look into app services.
Okay, thanks.
Yep.
But the Bicep template could deploy the code into that app service?
Well, the code won't be sitting inside the Bicep file, but you have to make some references to where the location of your application is in order to
storage account with a key in the.
Could be a storage account, could be an Azure pipeline.
Okay.
Yep. All right. So carrying on. So I was showing you the portal. Previously, the resource group is empty. So upon executing the Bicep file, I should expect to see a storage account. And indeed, I saw it. It's right here, right? Location, as per our specification, is East US, even though the resource group is in a different location. And that's OK. You can have resources of different location.
Hey, another question. Can I extract a Bicep template from an existing resource group in order to move something to a different tenant?
Right. So what you do is a two-step process. You would export into an ARM template and then convert it to a Bicep.
Awesome. Thanks.
I'll show you this, actually. That's a very good question. Here is an ARM template, right? As you can see. So what you do, let me change my directory to that folder. ARM template example, right? Okay, let me delete this Bicep file. There you go. So just a JSON ARM template, right? Now I will use Bicep compile. So there are two directions. One is compiling, which means to convert a JSON to a Bicep file. There's also decompiling, which is to convert the Bicep back to ARM template. So if you want the syntax, you can go bicep -- help, and there's a very comprehensive. Let's scroll this up. Come on. Yeah, so a lot of commands you can check. Bicep build, which is to convert a Bicep into a JSON ARM template, and going the other direction is a decompile. So here we have a JSON file. So let's compile it to Bicep.
So if I had an Azure function deployed in that resource group, would the code go along with this magically?
That's a good question. I have actually not tried that. Let me get back to you. I'll give it a try, and I'll put the comments back in the meetup group afterwards.
Okay, no worries. Thanks.
Okay, so despite some error, it converted. Yeah, as you can see from the warning, right? A decompilation is only a best effort process. It's no guarantee that it's going to be 100% mapping between ARM templates and Bicep. So what you need to do is go back and review what has been converted, but it helps you like 90% of the conversion and fix anything that's maybe a compatibility error or something that's gone weird. You just go and fix it. Should be a very simple and straightforward process. So from that JSON file, you can see that it's converted into the Bicep syntax. And here's the before, the JSON. Let's see how many lines of code. It's pretty long, 152, and the Bicep version is only 102. So you save around 50 lines. All right, so hope that answers your question, the back and forth translation between the two formats. Getting back to the demonstration. Okay, so we're still dealing with a single file. So that I don't confuse myself, let me close this. All right, so part 2, I want to show you how to inject parameters into this template. So right now, everything is so hard-coded, right? Including the location, the name, and all that stuff. So let's put in some parameters to make this more dynamic. So why don't we deal with the storage name? The storage name, I don't like it being hard-coded. So to do that, param is the keyword. Let's call it storage name. Give it a type. So it could be array, Boolean, int, object, secure string. That would be great for like password, things like things that you want to encrypt, and string. So in our case, we don't need to encrypt the storage name. So just a string type. And I will replace this quote hard-coded string with that variable name. So with the Bicep VS Code extension, I already have this helper, right? Once I declare it, I can find it from the helper instantly without typing it. So let's make this even more complicated. Suppose we want to lock it into, say, a minimum length of 4 characters, maximum length of 24. We can do it using declaration, right? So let's say minimum length 4, maximum length 24, just like that. And the rest we're pretty happy with. So let's save it and redeploy it. Let's see if we still have we scroll up, did a bunch of stuff here. Yep. So we could change this to say add parameters, add params, make it shorter. Deploy to the same group and the same file. Now, because there's a parameter being passed in, we have to define it here. Storage name, that's how we name it. And we'll pass in a different name, TSPUG, lowercase, keep it lowercase, TSPUG 2021-0519B. See if that works. So as you can see, we could pass in different variables and create multiple storage accounts based on this single template. So if we were to repeat again with the name C, D, E, F, and we can just keep on going, right? So give this a little bit of time to provision. And there we go. And what we look for, again, is provisioning state. Make sure it succeeded, and we did. If we were to refresh here, we should see now 2 storage accounts. Takes a little bit of time for Azure to catch up, so just keep refreshing or go get a coffee.
I find it interesting when you deploy stuff and it says, it's deployed, and you look at the resource group and it's not there. And sometimes I find that refresh button you were just using doesn't work, and I have to do a browser refresh.
Yeah. Or even as drastic as logging out. Yep, I've seen that too. But rest assured, if you see the message provisioning stage is successful from your command line, it's done. It's just the portal takes its time to sync up.
To catch up, okay.
Yep. So there you go. You see the second storage account as provision. So we're successful. And there you have it using parameters. So the next thing I want to show you is using built-in template function. I think we're still doing good on time, right, Peter?
Yeah, I think so.
Okay. Okay, so using built-in template function. So let's see what we can do. Okay, I got it. Let's say we want to make sure the storage SKU is always using the values that are legal. So we can put in a SKU of, say, Donald Duck, right? Like that's not valid. So this is how we do it. Use the built-in function allowed and put in the set of values that we permit this parameter to have, which is storage SKU of string type. And we can even define a default value of something. So in this case, let's define what's allowed. And I have already typed that in Notepad. So I'm going to paste that in here to save me from making typos. So these are the values that if you were to go to Azure portal and you were to go through the UI wizard, you would have seen these values from the pick list. So I'm just repeating those same values to prevent people using this Bicep template from using anything that's invalid.
Is there a way to point that to the list of valid items rather than having to keep your template in sync?
Not at the moment. It's probably something that they will come up with in the future, like a fetch values, possible value. Yeah, that's something that definitely the team is always working on new features. We could suggest that in the, user voice.
Right.
And they would implement it if people vote enough upvote for it. Premium LRS. Okay, I'm cheap. I'm going to go lower, just in case I provision and forget to delete it. Okay, that's good. Let's see what else we can do. Storage. Replacing this. So instead of hard coding, previously, we're going to pass in, again, a parameter. And that's pretty cool. Redeploy. So this time is use template functions. That's the demonstration. Call that C. And actually, I could do something more. Like that's pretty boring what I've just done. Let's do one more. Let's call param location string and use another built-in function, resource group dot location. Instead of hard coding East US, I'm going to dynamically fetch whatever location is defined for the resource group and use it. So as you recall, I created my resource group in the Canada Central region. But so far, I've been deploying all my storage resources in the East US. So let's synchronize it using this approach. Okay. That's more interesting. So I have two things here using the allowed values and defining that, and also the location, fetching dynamically resource group dot location. So here, I would pass in that. Okay, just double checking before I press enter. Looks good to me. So notice that I didn't provide any value for the location because it's by default dynamically fetching it. But if you want to override it, feel free, dash location, pass in like central US or East US, West US, whatever you have. So let that do its provisioning. We'll check in a moment. Oh, done, succeeded, fast. So again, refresh a couple of times. So what we should expect is a third storage account being provisioned, but location will be matching the resource group, in this case, Canada Central, all right? So once that's showing up in the portal, we'll see that. Yep, seeing it's done, just taking its time to show up. And Peter, you're right, it's taking its time. Ah, there it is. I was gonna do a clear cookie thing like you did. But great, look at that. It's dynamically inheriting the location from my resource group using that built-in function. So those are the things you can do, right? So rather than hard coding East US or some strange location, you can just inherit it and have it synchronized with your resource group using this built-in function. Okay, so next, I'm going to define some local variables and use it within the Bicep script. Let's see if there's any question before I continue. You asking if deploying the code within. Oh, Roy, are you asking or are you answering? Roy? Okay, he might be away. Hey, Roy.
Hello, you hear me?
Yeah.
No. Somebody asked if like a code can be deployed with Azure Function. So I'll just help clarifying that for
go for it.
that person. But you guys discussed that was 20 minutes ago.
Right. Okay. No worries.
Okay.
I think you answered that, right?
Okay. Thanks for asking. Bye.
Yep.
Thank you.
Okay. Okay. So the next thing I'm going to do is define some local variables to be used within the Bicep template. So let's see how we do it. I think our script is getting long, so let me check it in. I have a Git here, so let's just check it in. Before adding variables. Okay, so just so that we can do a diff to see the actual changes that I've done. That'll be more visual for you guys to look at. Okay, I have created a version of the code in my notepad. I'm just going to paste it in here, and we can just study that differences. Okay, let's take a look at diff. So I made some changes, and I've declared a local variable, making sure. Remember how we define the storage name? We always have to be careful because it's globally unique across the entire Azure platform. So here I'm using a built-in function called unique string, which pass in the seed of resource group ID. It will generate a unique string for me without me having to make sure that it's unique across Azure. So that's pretty handy. Rather than hard coding, again, that's always preferred, is to make it dynamic. All right, so let's deploy this and see what happens. And in this case, we no longer have to pass in the storage name because it's generated using the unique string function. So we can take that off. We do have to pass in something new that I've introduced. I should have pointed it out earlier, but I'll explain that in a second. Keep it lowercase. Yeah, so what I've done here is to pass in just the prefix of the storage name, and the rest of the string will be created dynamically using unique string. So the prefix in this case is TSPUG, and we'll see a bunch of randomly generated characters once this is provisioned. So let me get this going. And wait for it to appear here. Flip back here to make sure that we have the provisioning state succeeded. If there's a bug, we have to troubleshoot it. And this is the second last demonstration. Let me see what happened here. Succeeded? Yes, perfect. I think we're doing well on time, 7:52. There we go. So as you can see, the prefix TSPUG and the rest of it is random generated characters. So this will guarantee you that you won't run into issues with conflicting names and whatnot. Okay, last example. Then we can all go home, but we're home. All right, last example is to show you how to do an output. So again, I'm just gonna copy and paste from my notepad the script that we have and do a comparison. So let me check in the change first. That one was to add variables. Oops. And now I paste in the changes and we do a diff. Okay, very simple. So to do output, basically use the output command, pass in the variable name of the type. So in this case, an object. What I want to pass back is the storage account property, the primary endpoint of it. Okay, so let's run it. Our expectation is in here. Notice the previous deployment is empty. So after we deploy this latest version, I would expect to see the primary endpoint being shown in this space here. Okay, so let's deploy it. Okay, just double checking if I have to change anything. No, I don't have to change anything, but I'll change the deployment name just so I could keep track when I check the log. So this one is to demo the output. And let that fly. Thanks, Raz. Talk to you soon. Thanks for coming by. Thanks, Eli. Oh, thank you. He's congratulating me on the new book. Thank you very much. Alrighty, so as expected, the output is showing me the endpoints, right? So if I do DFS, I have that endpoint, dfs.core, WindowsNet. If I do web, I have the web.core, blob, queue, table, file, and so on and so forth. Very convenient, right? Everything is dynamic. No longer are we hard coding everything within the Bicep template. So those are the things that you could do as you advance and make the template more advanced and doing the things that you need to do. On that note, that's all I have. Any questions?
Yeah, what's your new book?
Oh, did you join us late?
A little bit. I'm watching on my phone, so I didn't get the whole thing.
Okay. Let me see if I can show the slide again. I did an intro of myself earlier. So let me just turn off the screen share for my desktop. Give me a moment to get organized. And Almost there. Just bear with me.
I'll ask another question while you're loading. Is there any concept of storing these templates in a central repository and then having the tooling always know, hey, go look in the repo for all my templates?
Yep, up to you. You can store it in Azure Storage. You could store it in Azure Repos, which is recommended, so that you can construct your CI/CD pipeline. You can put in GitHub, which is independent, and fetch it that way. Or you could even have it, the old FTP folder way, like any accessible location is possible.
Cool, thanks.
After all, it's just a text file, right? So any place that you can stuff a text file is possible, right? There are good ways and bad ways. The best way would be Azure Repos. Okay, so on the screen, you see the books. I've written Cloud Analytics with Microsoft Azure, Azure for Architects, the 3rd edition, and also my latest one is the Azure Strategy and Implementation Guide. They are available on Pact, which is the publisher, so pact.com, I believe, is the URL, as well as Amazon and Microsoft. Courtesy of Microsoft, I think you can download some free e-versions of that. So if you were to Google, you can find it very easily. Hope that helps.
Cool.
Yep, great.
Any other questions? Yeah.
Just a note to the group as a whole. We lost Rez a few minutes ago, but he's actually going to be presenting next month on Wednesday, June 16th. So he's going to be talking about building an end-to-end low-code solution for Microsoft Teams. So leveraging Dataverse for Teams and Power Platform. So Tonian, that link is in the chat there. So have a look if you're interested.
Yeah, that would be great. Nice topic. Any other questions?
No, man, you answered everything.
Oh, thank you so much. Well, on that note, thank you for having me. It's been a lot of fun.
Jack, thanks so much for presenting. This was cool. So we're going to hit stop on the recording. That goes up on the TSPUG YouTube channel. So I've been getting better at putting those up within 24 hours. So I'll put a note out once that's available for people to be able to have a look at as well.
Excellent.
All right, thanks a lot.
Well, thanks everybody. Have a great rest of your evening.
All right, good night.
Thank you. Good night.